Okay, so let's go ahead and get started. I'm not sure exactly who was able to dial in through the Defense Connect online. So hopefully, David Hill is the web manager that's handling all that. So I think there are some folks that were at least going to opt in, including some of the overseas labs that were interested in listening to what Dr. Klein has to say. So this is a webinar, and there are mics in the room, although I don't know how well they get picked up. So the sidebar conversations may be advertised across the internet, so keep them professional. If you have a question during a question and answers, and I assume Dr. Klein would actually be open to discussion, since that's really a big part of this is a discussion. But in order for the people that are watching online to be able to hear correctly, we'll use a mic to pass it around. So I'll run the mic around or pick somebody that looks like they're falling asleep. So we've got some visitors from outside the building, and so it's always nice to bring together people that are interested in this topic, which is broadly vector and rodent-borne diseases. We'll probably have some discussions afterwards and have an opportunity for some of the people to meet. But let me just go ahead and cut this short and let Dr. Klein, because I know he likes to talk even more than I do. And I've sat in some of his talks, and he's got 41 slides, so we'll see how long that goes. But it's a great opportunity to have him all the way from Korea. Dr. Klein is a retired Army entomologist. He spent 30 years on active duty and another 7 as a reservist, so he definitely has his fair share of time in uniform. He retired about 6 years ago. He's an expert and recognized in our field, not only in vector-borne diseases, but broadly in field ecology and rodent-borne diseases, and he'll talk, I'm sure, about some of that work that he's leading now. In terms of history of assignments and some of his expertise, obviously with 37 years, he did a lot of work in a lot of different places, including right up the street at Fort Detrick. He worked at USAM. He also spent some time at the overseas labs. Some of you probably don't know that the Army used to have a lab down in Brazil. So he spent a fair amount of time at the SOCOM AOR working in Brazil, and also with his job at USAMRIID, he did a lot of work down in Central and South America. He worked at the overseas lab in Bangkok through AFRAMS. And currently, he's actually still in Korea. He's definitely developed himself as an expert in PACOM and the threats there. He's working through the Public Health Command, but he's had a long relationship with the Armed Forces Health Surveillance Center. Currently, he is at the Public Health Command Region Pacific as the Regional Vector-borne Disease Program Manager. But he's detached, and he's at their forward element in Korea. The only other thing I'll mention about him is he has a mosquito named in his honor, which is probably the only person in the room who can say it. So, Dr. Klein, thanks for joining us, and it's good to
Thank you. Thanks for the introduction. Since he took up half my time, I'll try to make this quick. The concept of my position with the Public Health Command is basically to establish a comprehensive vector-borne disease surveillance program in collaboration, and it has to be in collaboration with the U.S. Navy, the U.S. Army, GEIS partners, and even the Air Force. And we're talking about the overseas laboratories, U.S. Army, AFRAMS, Navy, NAMRU 2, and the Air Force, which is located in Okinawa. We're also going to work with foreign militaries and governments. We do work with Australia for like culicoides, for identification of culicoides, and then those culicoides get sent back to Korea, and they assay them for pathogens. The program components really include everything: a comprehensive mosquito, tick, flea, mite, rodent-borne pathogens, which are of medical and both veterinary importance. We also do epidemiological investigations. We provide information for mapping for vector-borne disease distributions and species. And we do outbreak response and Eventually, we hope to get into vector and disease control. And that's very important because if you're going to just identify what's there and you have no idea what to do about it, then you haven't really done your job. Now, I'm going to talk mostly about Korea because that's most of the information that I have right now. Again, I work with the Public Health Command. We have the collaborators up there. Funding is through GEIS. We also have Korea collaborators that we work with. And then we work through the 65th Medical Brigade, and I'm located physically at the Force Health Protection Brigade in Yongsan, Garrison, Seoul. It's not there. The diseases I'm going to primarily talk about are malaria and Japanese encephalitis. I'll touch on Chaoyang virus, and we'll talk about some of the limited tick-borne diseases and hantaviruses. Those are the primary ones I'm going to talk about. So Vivax malaria. Vivax malaria has been in Korea for years. It's endemic to the Korean Peninsula. 1945, Korea was divided into North and South Korea. And during the 1950 to 53, during the Korean War, you had about 6,000 cases of Vivax malaria. And most people were on prophylaxis. So you're looking at a lot of prophylaxis failures and probably didn't take it. The first year, they had 12,000 cases, people returning to the U.S. But that was prior to Primaquine being an approved drug. So after Primaquine is approved after the first year, they had very, very few cases because it took about 14 days for the ship to go from Korea to the U.S., and they took their Primaquine most of the time. So present day is very much different than what we saw during the Korean War. So in the 1960s, they had a malaria eradication program, and I want to point out that they had a lot of malaria right in that particular area in South Korea. Most of the malaria right now is located up by the DMZ. But in 1979, Korea was declared by WHO to be malaria-free. And shortly thereafter, the North Koreans said that they didn't have malaria either. But in 1993, it reemerged. And the question is, did it really reemerge in 1993 or prior to? Dr. Carl Mason, who's in the AFRIMS, he was in Korea at that time. He said there was actually U.S. cases of malaria, but nobody wanted to talk about it because it was a policy that they didn't want to upset the North Koreans. So, but by I didn't change anything. Okay, by 1997, North Korea said they had outbreaks. WHO estimated in 1998 they had 25,000 cases. By 2001, they had 300,000 cases. 300,000 cases, look at the total that you had in South Korea was a little over 4,000. So North Korea has a much bigger problem, and you look at the distribution of malaria in terms of what the National Center for Medical Intelligence says. We have a small area of high risk. North Korea has a very large area of high-risk malaria. Now, what has happened with us? Well, we had cases going up and we had cases going down, very similar to what you see in South Korean population and military. And all of a sudden, we had very low numbers of cases. What was the difference? We went from ill-kept tents, which trap mosquitoes inside to bite people, to air-conditioned barracks, which people now use the screen nets in addition to the air conditioning to prevent mosquito bites. And so, and if you walked into these barracks, they were, I think, minus 60. They were really frigid. And no mosquito is going to go inside those barracks. It's too cold. So that is the reason why. Now, why do we still have some malaria up there? Because people are going out smoking and joking at night, and they're exposed, and they're in their PT uniforms. And they actually you don't train as you fight up in warrior base oftentimes. You're in your PT uniform at dusk when mosquitoes bite. And that's an issue that commanders have to face, but malaria doesn't kill anybody, so it's not a, quote, a lot of concern. At least it doesn't kill anybody in Korea. Now, initially when I got there in 1994, because the outbreak occurred in 1993, I said, I predicted malaria go from here to here very rapidly. And the question was, well, why did you predict that? Well, because there's lots of mosquitoes. Anopheles sinensis is throughout Korea. I mean, you get lots and lots of bites down here from the rice paddy breeders or pool breeders, whatever. So you get all these mosquitoes biting. And so the assumption is that, well, why don't we have a lot of malaria down here? And you look at it and you say, well, there is some transmission. You had 18 cases annually down here and 28 cases on the average there. But you look up at north and you say, well, there's 750,000 or 100 cases annually up in that particular area. But then you start looking at the different populations and you look at the civilian population and you see, well, gee, there's not a whole lot, but there's some cases. But then when you look at the people are often exposed by the DMZ. If you track them down, about 50% of the people that they track down were exposed near the DMZ. So the transmission isn't occurring here, it's occurring up here in a lot of cases. You look at the Rock Army cases are very low. And a lot of these people probably did have some exposure up by the DMZ. Now you look at the veteran population, that's where your cases are coming from. Veterans are up here getting malaria. They're not taking their Primaquine because it's not observed. They just say, here, take your Primaquine. If you depart Korea at any time during the summer prior to the end of malaria season, here's your Primaquine, take it. They do not take it because of what they consider rumors that are going around that is going to affect them somehow. So they don't take it. And if you look at the number of veteran cases of malaria and the number of active duty cases of malaria, it's very, very similar. So that's what the situation is. Well, this could technically start malaria down here. You have lots of mosquitoes. You have veterans returning down. Again, why don't you have malaria? Okay, to understand the epidemiology here, prior to 1999, we had 6 species of Anopheles in Korea. In 1999, when I returned to Korea, I started rearing progeny broods for WRBU because that's just something I do. Raise them and send them back so they have specimens. And in these progeny broods, I started looking at them and I said, well, some of these are sinensis, but there's some that are lesser. So morphologically, I had 2 species in one progeny brood. I said, that's probably not right, and I probably mixed up the pans or something. Well, then it happened in the second group and third group, and I said, something's wrong. So I sent the mosquitoes back there, and I told WRBU, there's 2 species in one progeny brood. We cannot identify this morphologically. Something's wrong. So what they did is they started assaying them by PCR, and they found that there was 2 different species in that group. And initially we thought, and the 2 species I'm talking about are Anopheles bellenrae and the one they named after me, Anopheles kleini. Initially I thought that these were very rare mosquitoes and probably not important in malaria transmission. And the reason was we were collecting these mosquitoes at cow sheds, and the numbers of Anopheles bellenrae and Anopheles kleini were extremely low. For 50 progeny broods, maybe I think we got like 3 or 4 kleini and about the same number of bellenrae. So I thought, that's not important. Sinensis is better. Well, when you start looking at the distribution, if you collect mosquitoes at Warrior Base, 50% of the mosquitoes, at least 50%, are Anopheles kleini, Pullus, Leicesteri, and bellenrae. Anopheles sinensis only makes up less than 50% near the DMZ. If you collect south of Seoul, 90% of the species that you get are Anopheles sinensis. These species, very, very low numbers. In terms of percent, maybe you get 1%, 2% kleini, and the same for the others. So very, very low numbers, very different the distribution. And so when you start looking at malaria, the epidemiology, this will start making sense. That why do we have malaria near the DMZ is because we've got these species. Now the question is, well, which one of those are vectors? The answer is we really don't know yet. If we look at understanding the vector here a little bit, sinensis, the data that we have, probably vector competence low to moderate. Probably a secondary vector, probably zoophilic. Nobody's done studies on this to determine whether these are really anthephilic or zoophilic or what the situation is. Leicesteri, this was actually synonymized with Anthropophagus in China. In China, Leicesteri is a primary vector of malaria. Indications are it's anthrophilic and vector competence probably moderate to high. Kleine, very similar, but it's north-central. If you look at Korea, it falls under Panmunjom. If you look at the north-central area, that's where you find large populations of Kleine. Based on the information we have, which is very limited, vector competence moderate to high, and probably anthrophilic, because if we collect near Tick-borne, we get more of the sinensis. If we collect at Warrior Base, we collect more Kleine. And if soldiers aren't, if we collect the mosquito magnets, if soldiers are not there at Warrior Base, then we don't catch very many. Polis is a very early mosquito. You find large populations May and June. They go down. This is, we got some indication that they're not a vector, and other indications that they are good vectors. So again, we don't know. We don't know whether they're anthrophilic. Velonray and Cynaroides, those were not incriminated as vectors previously, but now we're finding out they're infected with malaria. We just don't know how many sporozoites they have. Are they good vectors or bad vectors? We just don't know. So in 2010, we got permission to actually go up into the DMZ. And what we're looking at, this white line here, is what's called the MDL. That's the military demarcation line. And that separates the DMZ into two halves. The southern half, which is South Korea, and the northern half, which is North Korea. The only village on the southern side that's allowed inside the DMZ is Tongduchan, this village right here. And we put a mosquito magnet right here. It's less than 500 meters from the MDL. So right over here is North Korean property. This is South Korean property. We also collected at the Neutral Nations Camp, which is right at Panmunjom, and we collected at Tongduchan, which is about 3 kilometers south of the DMZ, and also Warrior Base. Now, I'm going to only look at the data from Taesongdong right now, but what I want to show you is that, and we had a problem with the mosquito magnets right here. In 2010, you can see we had fairly high populations of Anopheles species. And for some reason, we've noticed that the Anopheles species populations, they go down. They go up and they go down during the mosquito season. We don't really understand why, but it's been reoccurring over several years, so there's something affecting. So why do we have large populations? Well, look at the rainfall. Moderate rainfall. Clear through the end of, near the end of September, and then it dropped off. So we had lots of breeding sites during that period of time. 2011, and I have the weather data for 2012, but I don't have the mosquito data. 2011, we had rainfall so heavy, we had 26 inches of rain in 48 hours. Most of that was in 24 hours. We went up to the DMZ area, and you could not see the rice. It was inundated with water. In other words, it just flushed everything down. So we didn't have any larvae to go ahead and do the adults, and probably the rainfall probably impacted upon the adults as well. But thereafter, we had low rainfall. So all these places kind of just dried up. And so you didn't have the populations. Look at the populations, look at the distribution of Anopheles mosquitoes, very, very low. And if you go back and you look at the distribution of malaria, the malaria has gone down since 2010 in the Korean populations. It went down from 2011, again in 2012. In 2012, we had a semi-drought in the northern area. So places were drying out. So we had very low populations of Anopheles mosquitoes. Now the Korean government probably thinks they're doing a wonderful job in controlling malaria, when in fact it's the weather that are controlling malaria. Japanese encephalitis is present on the Korean Peninsula. It's caused by a virus. Primary reservoirs are large water birds, and wild and domestic pigs are amplifying hosts. Inside the DMZ, you have a number. It's unmanaged land. There's nobody going in there and doing it. So you have all these abandoned rice paddies, which create pools if there's water there, and you have these wild pigs and deer and stuff running around inside the DMZ. The mosquito, the primary vector is Culex tritineurincus. And in the south, it's a very early mosquito. In the north, it's a very late mosquito. And probably, what I'm assuming is probably slowly migrates up from the south as the weather conditions, because we don't see large populations beginning until late July up by the DMZ. But you see populations in June that are higher, much higher in the south. So it's warm enough so it's not overwintering eggs. The eggs don't overwinter as far as I can tell. Worldwide, there's about more than 60,000 cases annually, and that's way underestimated. What they're seeing there is severe cases. If you go to a hospital, they report it. If you don't go to a hospital, they don't report it. And it can in maybe 4 or 5 days, you'll recover from it. But even mild cases, they found that if you have a mild case of Japanese encephalitis, it causes sequelae on the brain. And while you don't detect there's a difference in the way you act, if you take tests, they can tell that there's a difference. So it does affect you. There's only 1 in 200 actually infections for all the transmission. So you take 60,000 cases and you times that by 200. What is that, about 6 million transmissions? There's a lot of transmission going on, and that's probably a lower estimate. Of those that survive, there's about a 20 to 30% mortality rate among those that are symptomatic. Of those that survive, 30 or 50% are going to go ahead and die later on, or have serious problems, be fed by tubes or whatever else. The treatment is supportive care, but there is a vaccine. And currently, the Koreans are vaccinated. The U.S. Army is not vaccinated. That's being reviewed because they had a recent death, recent documented case too. If you look at the history, you can see that Korea has problems with Japanese encephalitis. 1949, they didn't have very good surveillance at that time, but you can see they had over 5,000 cases, 50% of those died. So you know that there was a lot more cases than 5,000. During the Korean War, no reporting probably because of the war. We had 300 cases documented in 1950. Thereafter, there was no reports of Japanese encephalitis. Most of those were down in Busan. Busan is a very southern portion. So after they got the vaccine going, you can see the number of cases they had here. Going back to 2010, they had an outbreak, actually, 26 cases, 7 deaths. And again, if you go back to the rainfall that I talked about in malaria, that's the reason. In 2012, they had 21 cases. The one yellow one up here is a U.S. airman, recently retired, 42 years old, died. So that's the only documented case that we've had in the last 20 years. And I say documented because if you come into the 121 with encephalitis, nobody tests you for Japanese encephalitis. You either have meningococcal, bacterial meningitis, or you have viral meningitis. Nobody tests you to see whether you have Japanese encephalitis. We have no records of people with Japanese encephalitis. So when people say, well, there's no evidence of Japanese encephalitis in our people, because it's not tested. So the age in the Koreans are usually more than 30 years old because that's when they started the vaccine. That's when they mandated it. So that what we're seeing is mostly, but we do get some children. Vaccines not 100%. And the vaccine that the Koreans use are mouse brain, and they have some reactions, so they modified the vaccine proposals that they have. The U.S. right now, they have a vaccine that's cell focused. So it's a much better vaccine, and they're trying to get it. But there is a cost to that. So 2010, look at the distribution, and again, go back to the weather situation. Lots of rain up in the near the DMZ. We had 1/3 of the cases up by the DMZ, north of Seoul. 2011, the flushing action. Mosquitoes never recovered. The flushing action was throughout Korea. We had 3 cases. This was very early. This was in May, prior to the flushing action of water. Semi-drought this area. No cases. All the cases are south, which had remnants of two types. So they had rainfall. North didn't. Now, one of the things I want to point out is there was a child here 7 months old. So that was prior to getting cut. So the one thing I want to point out too is that U.S. military are not necessarily exposed at their place of where they reside. They're exposed oftentimes when they go out. If you look at 2010, look at the number of isolations or detections that we got. We got over 80 detections of Japanese detections. Over 80. 2011, we got 0. 2012, we're waiting to have the mosquito nest. So we don't know what's going on there. But there's very few Culex tritoniericus from the northern area. Probably, we don't expect very many. We had 97 serotype 1, 1 serotype 5. Serotype 5 is very different from serotype 1 through 3. So whether the vaccine covers that or not is a question of, at least on my part. I don't know that much about vaccines, so I'll just question them at this time. 2010, we have the data for the weather. 2011, there's no case, no infection, so we didn't put that up there. But you can see the actually infection rates that we see here, 10%, 9%, 21%. So just because at the later season, just because the population is low, the infections go up, so you have to still use precaution. And this is all the serotypes. This is all done at AFRIMS. Very competent people in AFRIMS, and very really happy to have them working with us. But you can see here that all these are serotype 1. We had the 1 serotype 5 down here. Very different if you look at the distribution on genotype. Very different from serotype 3. And in 2009, genotype 5 was identified in China, 2010.
Colonel Schuster's listening, so it's good that now you can pay it.
Okay. Chaoyang virus apparently is a mosquito virus, but we're the ones that really picked it up. Actually, Dr. Lee at USAMRIID discovered it from mosquitoes that we were collecting in 2003, but he never got around to publishing it, so the Chinese published it in 2008. So they got credit for discovering the virus. We found it in 3 different mosquito populations. Aedes vexans is a primary one, Aedes albopictus. But it doesn't affect people, but it's very close. If you look at phylogenetically, it's kind of in between dengue, Japanese encephalitis. It just doesn't grow in barrel cells. Korean hemorrhagic fever, 1900, suspected outbreaks of hemorrhagic fever throughout Eastern Europe and Korea, other places. 1950 to 54, there were 3,000 cases of Hantavirus in Korea. 1978, they finally found out what it was, what the reservoir was. It's Epidemus aquarius, it's striped field mouse. That was the picture you saw in the first one. And the causative agents of HFRS and HPS are rodent-borne viruses that are transmitted by aerosol or bite. So you don't want to handle these things and let these mice bite you.
You had a good time?
The outbreaks in Korea occur from September through December. The epidemiology of hantaviruses in Korea is very, very different from European hantaviruses.
What are you guys up to today?
If you look at hantaviruses in Europe, populations of mice go up, hantaviruses cases go up, populations decline, rapidly decline, hantaviruses rapidly decline, they build up. They're very sick. In Korea, we have approximately 400 cases of hantavirus.
You guys don't want to go to.
Our rodent populations are very stable. We don't have the populations that go up and down, up and down. If you look at seasonally, they're almost
You guys just come up with
a little bit
every
different,
why.
but not much.
Good Lord.
This is what we're dealing with in hantaviruses. We actually have 5 hantaviruses in Korea. This is the bad one. This is the one that's identified because it's more severe.
Reasons for why.
If you look at Seoul virus, we had one airman that got Seoul virus in Yongsan Army Garrison because
really
vacuum a place that was infested with rats, and there was rat feces all around, and probably no better way to get hantavirus than to vacuum up infected rat feces. They almost missed the case. They only picked it up because he had protein in his urine, and they said, okay, let's check for hantavirus. Lo and behold, he had. So Seoul virus is probably underestimated. Epidemus peninsulae, this is usually a high elevation rodent, so we don't have people too high elevations normally. And then you have Myotis regulus, which is a vole, which is again high elevation, but we do collect them in low elevations. But Muju virus is very similar to Kumala virus, and it's not as severe. And then we have Imjin virus, which is in shrews, and there's no evidence at this point that it really causes human disease. It falls in that group. So this is what hantavirus cases look like, and it looks like, well, gee, it's going up. This is just better reporting. So they're doing a better job of reporting. You can see the cases here, around 350, 400 cases normally. What's it look like for the U.S. Army? We had an outbreak in 1986 prior to when we got the records for 1988. We had 2 deaths. That was in Marines. And then thereafter we had 0 to about 9 cases annually, on the average about 3 or 4 cases. In 2005, we had 4 cases. We were actually able to get the blood from the patients, isolate the virus in the blood, and sequence it. And then we collected rodents from the areas where those soldiers had been. And we were able to, because it changes over the distance the virus does, we're actually able to identify where they got it. And because we were able to identify where they got it, then we could identify the activities that was associated with that.
Which picture is that?
A bad activity is firing artillery. Because when you fire artillery in a rodent-infested area, what do you get? You get backblast from the artillery shells. And that dust just blows right up the nose. If you're, the other 3 people that got it were cavalry group, and what do? They run up and down roads in cabs. Dust comes in cabs, concentrates, and that's where they got it. One of the things about this group right here, there was 3 people in one tank of hantavirus. So be in an enclosed vehicle, dust coming in. You want to be in the lead vehicle if you're, don't be following somebody. That's a risk factor. Now, we never had 2 years in a row with no hantavirus cases. So what we did is we identified all these places that had hantavirus risk, and we told the training people, do not go to these places during a high-risk period. And I'll show you the high-risk period. And so we haven't had any cases until 2012. We finally had 1 case. And that was at Warrior Base. We've had cases there before. And they were doing inappropriate things, probably, or things that would transmit hantavirus. So what we're looking at, by collecting all these rodents and stuff, we can figure out what in the heck's going on. You look at the cumulative data here, and it just kind of trickles along here, and all of a sudden, around end of September, October, it goes up like that. And then it just drops back down. Every year, same pattern. Well, why is that? Well, it probably has to do with this right here, reproduction. In the spring, you have reproduction going on, and you say, well, why don't we see a bump in cases? Well, in some cases, they actually did previously. But what happens in this situation right here, you've got this reproduction going on, but you also have habitat expansion. You don't have the competition between rodents. Because during the winter time, well, right here in the fall, August, September, we have this huge, large, very rabid population, large reproduction. Most of those rodents don't survive, though. But you have habitat restriction. All the vegetation is drying up, and areas where have the large types of vegetation drying up, it's not conducive to survive. Because once there's bare grounds, things can see you and eat you. And so there's competition for these limited spaces, and so you get acute cases of hantavirus in rodent populations. And that's why you're seeing this. So this is the high-risk period. Most of the places you can go out and train during the year. We do have cases on, like in March and June, stuff like that, but they're scattered cases, just like the Korean. But this is where we have most of our cases during that period. But the other important thing is we cannot predict any one spot that's going to be high risk this year. And you can see from our trapping, and we collected quite a few rodents at these places. You can see here it's high at one spot, very low here. Sometimes it's parallel, sometimes it's not. Very, very difficult to predict during the high transmission period of right in here what's going to happen. If you have during the wintertime, if you have high populations here, that's probably going to be high risk for the transmission of hantaviruses. Very different. Also, transmission to the rodent is probably by bite, because you see here it goes up with age. So as rodents age, then the hantavirus rates go up in them. And there's also evidence for soul virus. People have done a lot of stuff in Baltimore. There's more scarring. Rodents that are infected with hantavirus have more scars and so forth. So there's indication. Most of the transmission is by bite. If you look at laboratory situations, if you have a rodent in one spot and a rodent on the other side, that rodent on the other side, if it's negative for hantavirus, will become infected. Situations very different in laboratory situations because you have dry bedding that's going to aerosolize, because rodents are going to be scurrying around in their aerosolized material, and it's going to go over the other area. In real life situations, those tunnels don't have a lot of dry bedding, not to that degree. These are the areas that we've looked at very briefly. And if you look at the capture rates, you can see that this is what we've captured. Now, these aren't all equal. For example, LTA 3637, we only sampled at one time, and that was because the people that the person got hantavirus was actually there. So we sampled it. We didn't catch any infected rodents at that particular time. Had we collected over a period of 5 years, we would have probably picked up some. But the other indication here is that if you are north of Seoul, the chances of getting hantaviruses are much higher than if you're south of Seoul. This is north of Seoul, these areas right up here. This is hantavirus infection rates. You go down to Camp Humphreys, hantavirus rates are usually less than 10% at any one particular time. Up in these areas, we get hantavirus rates of 30 to 60% on occasion. Very different. Osan Air Base is the same. At Hanam, Gwangju is very south. All these areas are south right. Very, very low hantavirus rate. So as you go north, there's more hantavirus. Ticks. We've collected a lot of ticks, and I'm just briefly going to touch on it. We picked up tick-borne encephalitis in Jeju Island. There are spotted fever group rickettsias there. Dr. Zhang has just published an on that rickettsia census is there. The other rickettsias, we don't know what species are really there. Ehrlichiosis is there, Bartonellosis is there, anaplasmosis, babesiosis we don't know anything about, but likely there. So because it's not reportable, we don't have much data from the Korean population.
So have you looked at the rodent populations for anything other than Hantas?
Yeah, we looked at them for strep typhus. We looked at them for leptospirosis. Leptospirosis is not very high in rodents. We looked for marine typhus. They're infected with that. From the fleas, we've actually gotten Rickettsia felis.
So the Koreans testing all those, or you sent?
The fleas and stuff go to Seoul National University in Korea, and a lot of ticks do. Kongguk University, a lot of ticks and some of the road tissues go there for Rickettsia. So what I want to point out, though, is the ecology of Korea has really changed. This is what you saw during the Korean War. Right, this is what it looks like today. You have houses built right into these areas right here, little farms. So the exposure is a lot greater. The U.S. Army is also exposed to a greater disease with these because the fauna has changed so much. Now it's harboring different kinds of animals, and the potential for harboring different kinds of pathogens becomes greater as well. So if it's not diagnosed, then you can have people die. There was a little girl died of strep typhus, misdiagnosed. It was a Korean. We've had, maybe I shouldn't say this, but there's a disconnect between medical providers and PM. We had 2 cases of empirically diagnosed strep typhus this year. People came in with eschars. One person, serology was sent off because they don't know anything about rickettsia, tested for strep typhus, came back negative. Did not take a biopsy of the eschar. We weren't notified until after the fact. Soldier came in, the same thing. This soldier had a titer of 140 for strep typhus, probably strep typhus. No convalescent serum. So the only thing we can say is this lady was exposed to strep typhus or seropositive for strep typhus at some time in her life. We don't know. And because we didn't get the eschar, we can't strain type it to figure out where she actually got it because the strains differ from one end of the peninsula to another end of the peninsula. So we need to have the providers tell us what's going on, not to get it out of the medical system at some later date. And that same thing happened with the Hantavirus. Had we known about it, we were unable to get the virus from the blood. Had we known about it sooner, we could have got blood from the patient several times to isolate the virus, detect the sequences, and find out exactly where we got it. Now what we're doing is we're going back to the sites where he's been. We have to base, well, did he get it here? Well, the rates were this high, capture rates this high, and we have to correlate. We can't document exactly where. I think I know where he got it. So, but that's just me thinking. I've been wrong one at a time in my life. Maybe I'm wrong again.
You're married. You've been wrong more than that.
So when you look at strep typhus, all of a sudden, this was better reporting right here. But all of a sudden, they got this huge bump here, and they don't know why. And one of the reasons may be that the Koreans used to just give antibiotics out. If you went to your pharmacy, you got antibiotics. Now, at some point in time in this area right in here, you had to go see a doctor to get a prescription to get the antibiotic. So you had to be diagnosed with strep typhus. Now, these are confirmed by KCDC. So if you had rickettsia and they tested it for strep typhus, it would come up negative. So there was probably more cases than that's going on. Dr. Richards, who's sitting in the audience here, soldiers in the 1990s found out that 0.2 were seroconverted while they were here in Korea. However, rickettsia spotted fever group, 2% seroconverted while in Korea. So most of the cases that we're probably seeing, and if you're looking at scrub typhus, and these are confirmed cases, if you're looking at 6,000, that's 0.2, you got what, 10 times? Probably rickettsia transmission going on? We don't know. Some of the issues in shortfalls, the 65th Medical Brigade is a level 1, level 2 support MTOE. They do not have facilities to test anything for anything in bugs, rodents, or whatever. They have to rely on others to do that. The only thing they currently do is mosquito surveillance. They could do tick surveillance, but they're not taking that mission. They could do more rodent surveillance, they're not taking that mission. They're doing primarily food and water and not doing a lot of the entomology mission. We currently have 10,000 Anopheles larvae at WRBU, and that was from me going up to the DMZ bi-monthly, collecting larvae at the same spots to determine where these larvae were actually breeding. And we based that, we collected the first instar, second instars, third instars, fourth instar. If they're first and second instars in that habitat, that's where they're breeding. If they're third and fourth instars, they may be coming from someplace else. And if you only find third, fourth instars in those habitats, likely it's not a breeding site. And what we find is in the streams, in the ditches and stuff, we find third, fourth instars. They're not breeding. They're breeding in rice paddies and pools. Now, again, and what's the difference between why the distribution of Anopheles declining in Pullus up by the DMZ and they're not south? If they're breeding in pools, rice paddies are pools. The other thing we found is that if up by the DMZ, if you look at the population of Anopheles sinensis in June, it accounts for about 5% of the population. By the end of October, it accounts for about 70-80% of the population. Now, what can that do to malaria? If you have latent malaria, is basically dependent upon the number of sporozoites that are injected. If you have a very good vector, lots of sporozoites, it's going to be non-latent malaria. If it's going to be a poor vector, a secondary vector with just few sporozoites, the chances are that you're going to have latent malaria. Latent malaria from Anopheles sinensis, if it's a poor vector, is then going to translate to you're going to come down with malaria and it's going to restart it next year. So maybe there's some things working here that really don't. Afrims right now has 70,000 culicines from 2012, and we need to get those identified, but or see what's in them, but there's no funding. Just noise. And I talked about PM notified after the fact. This is important. WRBU just discovered this, Janelle, who's here in the audience, that if you use one of the assays that was developed for humans, you get positive results if they're infected with fungus. And one of the fungus that she's identified is one they use for biological control. So what does the previous data mean for malaria infection rates? It may mean that maybe 50% of those were positive. In reality, maybe less. Don't know. Some of the shortfalls that Korea has is personnel, mostly untrained, and they rely upon, oftentimes, for me to go out and help them get trained in collecting rodents. That's not a difficult task, even collecting mosquitoes and so forth. So, but they do have 2 entomologists, very good entomologists, working at the 5th Med.
Who are they now?
Dr. Kim.
Oh.
And Korean. Mr. Chaoyang. They're both Korean. Arthropod surveillance, routine mosquito surveillance they're doing. DPW chose not to collect mosquitoes, assist in collecting mosquitoes in the DMZ. If we hadn't set out mosquito magnets this year, we would have 0 data for Warrior Base in that area. But we set out the draft, so we have the information. And some of these things are long-term, you can see, because of the temperature, and or not the temperature so much, but the precipitation, to figure out what's going on, what the risks are at that particular time. I thought I could predict everything, and then this last year messed me up because I assumed there was not going to be any JE. I wasn't looking at the south, I was just looking at the north. I was wrong again. Okay. Some of the solutions, the Public Health Command has to work with find what the requirements are. Once those requirements are identified, that filters down to the medical detachments to go ahead and do, and other support people to go ahead and assist them. So one of the things we need to provide them is capacity building if they're untrained in certain areas. We need to know how to do. A typical example is, and Major Davidson was over there, but he did a real good job of it. But right now, on the rodent surveillance, I said, well, we need to go ahead and do some epidemiology here to figure out where they got it. The commander sent me 3 Korean soldiers, not a U.S. soldier, to be trained to be able to go out and to suggest how to do this stuff. He sent 3 Korean soldiers. We're supposed to be training U.S. people as well as the Koreans to help us. So what do we need? We need support from GEIS or some funds. I mean, basically my position is paid by GEIS. Okay, Guam and Palau. The reason we went to Guam and Palau, the original topic was to go to the Philippines. Because of certain conditions that I'll discuss later outside of this, we could not go to the Philippines and do the work. So I talked to Colonel Fukuda. He said, well, why aren't you doing Guam? Because there's a large contingency of U.S. people there. Also, the Marines are moving from Japan down to Guam. So ecologically, that's going to affect what's going on. You're going to have greater exposure, perhaps, to disease. Philippines has 7,000 islands, or 700 islands. All of these, I mean, they're just island after island. We can't do every island. So we have to pick and choose and say, okay, which islands are we going to get support from to go ahead and try to do, because we can't stay there for 20 years. You go there, you set something up, you establish it, and hopefully they will continue to send you the information. But you set something up so that they can go ahead and do it. In Palau, we also got support from the ambassador there, very excited about some of the work that we're going to go ahead and do there. Don't know where to point this. Again, I want to point out this is a collaborative effort. This is not my project per se. It's a project with the Public Health Command, AFRAMS, NAMRU-2, the U.S. Air Force School of Aerospace Medicine, Depth 3, and then we have to work with the governments and military of Guam and Palau, and as well as other GEIS partners. For example, if we collect ticks, they have to go somewhere. They have to be assayed, and they have to be identified. So they have to go somewhere to be identified and find out what's there. Because otherwise we won't know what the risk is. If we just collect ticks, we say, well, there's this species, we haven't done our job. And again, support really is GEIS partners, military, and the Department of Health and Palau Ministry of Health, with the Department of Health Guam and Ministry of Health Palau taking the lead. Now, why am I saying they're taking the lead? Why isn't the Air Force taking the lead there? Why is Navy taking the sailors, airmen rotate every 2 years. They get new people And it's not that they are incompetent, they're not trained. The Navy had one person there that was doing mosquito taxonomy out of the schoolhouse, recently out of the schoolhouse, using the schoolhouse key to identify mosquitoes. He was doing his best job that he could do. Very dedicated, but he probably wasn't identifying everything correct. He didn't know what to do with the mosquitoes. Like, he opened up the freezer, and there was mosquitoes sitting in the freezer. I said, well, they're probably not good for virus isolation at this point because the virus degrades. So that's why the Guam Ministry of Health and Palau Ministry of Health, they have to take the lead. They have to be the focus where if the Anderson Air Force Base or Navy has a problem, they can go to them to get the solution. But they are limited right now in people. Now the Guam is actually building up. They're building a multi-million-dollar facility, and they're asking us, what do we need? Well, first of all, you need somebody that can identify mosquitoes. You need somebody to collect mosquitoes. All the things to do. The assay of the mosquitoes comes later. If they ever develop that capability, which I'm not sure that they need, it'd be better to take those mosquitoes and send them off to a laboratory that has facilities to do. And I'm saying some laboratory like AFRAM, get some Cassie and maybe Dr. Richards here, or someplace where really they know what to do. Here's some of the issues that they have. The local population just tolerates mosquitoes. They just tolerate it. They have Aedes aegypti and Aedes albopictus at Palau. They also have dengue. They do not have Aedes aegypti in Guam. They do not have. They have Anopheles sinensis on Guam. We don't know what species. So what's the risk of getting malaria? If it's sinensis, the risk is very low compared to maybe if it's Anopheles lesseri or some other species. Anopheles lesseri has been identified from Guam. Morphologically, you can't tell them apart, so we know what they have. Ticks are extremely abundant. Look at the ear on this cow. I mean, if I blew up this picture, all these little tiny brown spots, those are all ticks. They have, in Guam, they have 20,000 feral dogs. In Palau, they don't have probably quite that many. They probably have 19,000. But they have a lot. In Guam, they have wild pigs, they have deer. So they have ticks on those animals as well. They have other animals. Of course, they have the brown tree snake, too. We haven't found any ticks on those. Shortfalls, again, is mostly on trained people. Mosquitoes, it's limited surveillance. At Anderson Air Force Base, they collect mostly at housing areas or places like that. We went out the end of the runway, and we were getting eaten up by mosquitoes. We suggested maybe they set a trap out each of the runway to figure out what's there. There is no surveillance for ticks, fleas, mites, or rodents or anything like that. And there's no current vector-borne pathogen surveillance. So we don't know what's there. The Philippines, not 700 islands, 7,000 islands. Wrong again. There is a combined U.S. multitask force there. It's in Mindanao. And initially, the thought was to actually go to Mindanao and work there. It's a high-risk area, though. And the only way, perhaps, to get in is if you take military flights and you're surrounded by military. So it may be something that we can't do. And that's what I'm trying to find out on a fact-finding mission when I go back there in the Philippines in December. The immediate concerns for vector-borne diseases are malaria, Japanese encephalitis, which are just, these are sporadic outbreaks, dengue, and chikungunya, which are primarily urban, and then they have scrub typhus. In World War II, there was a unit that was 50% of the population came down with scrub typhus. They were unable to go do their mission. So scrub typhus is an issue. I guess I'm done. So,
Must be.
any questions? Yeah.
A question in terms of
Hi, this is Jim Cummings from Geist. Can everyone hear me in the room and online? A question concerning the malaria diagnostics or surveillance that you were doing in Korea. You mentioned that it was confabulated with cross-reaction with fungal presence. Can you speak to what that exact assay was, and is that specifically for Vivax, or was that across all malaria strains?
Actually, I'd have to refer to Janelle on that. It's specifically for Vivax. But right now what they're doing is we have the 2011 mosquitoes at KNIH. They're running 2 assays, and then after they assay them, they're actually sequenced to see if it's really malaria or not. They're very slow at doing this. We need a 2012. Go ahead.
Okay. The assay that we're using was first designed by Sununu, and it's in the 18S locus, and somebody had done, or no, sorry, not Sununu, Rubio. No, the Sununu primers were the ones that picked up the fungus, but we tested 4 different primers sets. 3 of them were for 18S. Both that was Sununu and Rubio et al. And the Rubio primers were used by Lardot et al. And that is published in the CDC's MR4, which is the manual for testing. It covers a bunch of topics in malaria. And both of those primers had false positives. Most of it, when I ran it through NCBI, was unidentified, which means it was probably an uncultured bacteria. And then we also looked at PDR47, which is a marker that they found through data mining, and that also detected false positives. In fact, that gave us like an 80% infection or something crazy. So the one that works that we found is published by Steenkest et al. In 2008. And it's a cytochrome B marker, which is good because it's far more sensitive than 18S. And it's a nested PCR. The only problem is, it's not a problem, it's something you should be doing. You have to sequence it to identify the species of malaria. And a lot of these original studies did not sequence the results in mosquitoes. They just assumed that they were getting what they were supposed to, and oftentimes it's even the correct size. The band is the correct size, but the wrong type of organism. And both the Sununu and the other 18S primer for Rubio were Vivax specific. It's a nested PCR. The second round is species specific.
And just one comment, sir, again, Jim Cummings. Thanks for a great lecture. Was that JE vaccine that is used now in the United States was first made about 200 yards from here, the rare pilot bioproduction facility.
The problem that they're facing right now in Korea, because it's going back and forth, they have to find a bill pay. And that's the really issue. It's, I guess you have to consider, I guess, how many deaths would it cost, and so forth, because it will be expensive.
So we've got a question from Lieutenant Sutherland, who's the entomologist at NAMR 2. Any additional comments on pitfalls or unique challenges with executing tick field collections in Korea?
The challenges are for the medical detachments actually to do the tick surveillance. One of the issues that the medical detachments have is we collect ticks oftentimes not necessarily on bases, because if you want to find out the distribution of all these ticks and the diseases they carry, you have to do it throughout Korea. And the Koreans, the Katusus, they can't go on TD1, and the medical detachments do not have any funding. So they're very limited actually to they can do. If you send somebody up, 5 hours to go do tick collection, you have to send them 4 in the morning. They have to come back at 2 in the afternoon, and that's an issue. They really need to be at the locality so they can actually work, and that's a challenge. And then, of course, we have to have people identify the parasites.
So this is Lieutenant Colonel Richardson from Malaria. Let me just make a follow-up comment that, we see this as a sustainability and a logistical issue wherever entomologists or preventive medicine personnel or public health personnel are working. The effort that it takes to go out and put out mosquito traps or do tick surveillance is simply overwhelming and unsustainable. And so through the research and development process, we're very focused on developing solutions to fill that capability gap. The capability gap being that we don't have sustainable autonomous or semi-autonomous or standoff capability to do biosurveillance or vector-borne disease surveillance. So the next generation concepts to the CDC light trap that was developed in 1961, which is still the gold standard, or your mosquito magnets, is all old technology. And so we're very interested and are working with partners now that are interested in funding what's the next generation of something you can just put out there. Mosquitoes are attracted to it because it's got a great thing that smells like humans, and there's some pattern recognition process that takes out the user challenge of your young entomologist that's using a key that was developed in 1960 as well and only has 24 hours in the day, and he's got 10,000 mosquitoes to identify. So I think, Lieutenant Sutherland, that's a long way of saying that we need better tools to more efficiently do that sort of thing.
So, for example, in Palau, they do not have dry ice.
Just you and Bryce.
And they use CDC light traps, and I've been told there's no inoculum there. I don't doubt that they're not catching.
Well, we happen to be working on a dry ice alternative.
Oh, tonight they have to go to work tomorrow.
Major Long, I do have a question going back to the rodent surveys and the cases. You mentioned a geographical predictor, but it looked like, is there a way you could predict potential cases from the rodents, from surveillance? If you have enough data to go back.
What we did is, based on the trap rates, the infection rates, classify those as high risk. What happens, you can't go out on a year basis and do it. Reason is the acute cases that are going to occur, those acute cases are going to be 15 days delayed before the rodents show antibodies. So if you go out at a particular time and select, you're going to have a lot of negative rodents when in fact they're actually back. So you have to assay all the spleens in order to determine that. I think you have to assay the progression. But there's a trigger mechanism that causes that focal group to expand. We don't know what that trigger is. But if we look at just rodent populations, I mean, it goes down in the fall a little bit. It'll come back up in the winter time. But on the average, if our drop rate is 30%, pretty much varies from about 5%. We don't have the upset. But to answer your question, if you just go out there and you say this is high risk, there's lots of roads, conditions are right, don't go there during high risk.
Just play the odds.
Yes.
Play the odds. You'll eventually get Hantavirus.
The camera card.
Anybody else have any questions?
Sorry. Just really fast, it's not as much a question as a comment. With the Sinensis thing, I would wonder
Here with me somewhere.
if maybe it was an issue of competition. I don't know if anybody's looked at that. Since if the habitats are similar, maybe.
I think part of it, well, it's not competition, I don't think, because if you look at the rice paddies, I think it's possibly we're looking at succession. because if you look at the rice paddies when they're young, there's very few sinensis. As the rice paddies mature, you're getting lots of sinensis. So it may be a succession of grasses that we're really looking at.
And then the other thing I would be wondering if the, I guess, military would really be interested in looking at is the idea, well, of climate change, because obviously the cyclical changes in mosquito populations are so related to weather that if there's a lot of expansion, range expansion, and also changes in malarial development because of changes in temperature. And I know there's people looking at it, but just an idea.
That was definitely.
Well, that really happened in 2012 at the DMZ. We had extremely high temperature for about 2 weeks. Like I said, rice paddies were drying up. So it really affected.
Well, thanks a lot, Dr. Klein. I know you got some follow-on meetings here, so we'll cut this off unless there's any final questions. The only thing I'll comment on is that we had Lieutenant Colonel Schuster from AFRAMS, Lieutenant Sutherland, and Gisela Vasquez, Dr. Vasquez, who's in the entomology program down at NAM 6. So that was nice, this work. It was also taped, so fortunately you didn't say anything inappropriately. What we'll do is we'll share that with specific people on a need, an as-needed basis. So from AFHSC or DIPSA or guys across the hall need that training. So thanks again. And David, I know you're listening. He's the webmaster, so thank you very much, David. It's great. All right.
No, I gotta wait until this is done encoding and it's almost done, and I can put that card in.
Oh yeah, come here. So I gotta give my grandkids extra help. Come here, come here.
See, I'm